Alright, so we're going to get started now on toolpath creation. We're going to go back to our sample 1 part, the very first thing we did, the part with just 4 holes in it. And what we're going to do is we're going to create toolpath for this. We're not going to worry about machining it to size. We're going to assume the block is already to size. Right now we're focused solely on hole making processes. And so we're going to do one exercise that's focused solely on hole making, one that's focused solely on contouring, one that's focused on pocketing, and then we're going to start putting it all together. So this is our hole making. We're going to do 3/8 ringed holes in these 4 locations. I'm just making them ringed holes so that they create, so that we're creating more than one tool. Yeah, I'm actually going to create 3 tools. So I'm going to go back to Gibbs and I'm going to open sample 1. This is in my way. All right. All right, so this is the sample 1 part, just the very simple part to draw. So up until now we focused on document control and the geometry palette. We've touched a couple of other things, but now we're going to go to cutting tools. When I click that button, it opens up a tile list on the left hand side of the screen. The tiles are numbered. To create tool 1, I just double click on tile 1. It opens up a page for me to describe what tool 1 is. Now by default the tool number is going to match the tile number, but it doesn't have to. That's what this tool ID number is for, if I want this to be a different tool number than the tile it's on. However, I recommend not checking that unless you have to, because it can get you in trouble if it's got a different number than you're expecting this tool to be. The options here are roughing and mill, finish and mill, ball mill, convex tip cutter, which is a high feed mill, a lollipop tool, a tangent circle mill, a barrel mill, a taper barrel mill, dovetail cutter, shell mill, face mill, fly cutter, a key cutter, a thread mill, that's a single profile thread mill, a full profile thread mill, a drill, a center drill, where you have a drop down to select specific sizes of standard, standard out of the box dimensions here. We can also do Form A, which is what you're going to be most used to in the United States, Form B, and Form R, which I think are mostly used on Swiss machines, but we're going to stick with Form A. Spot drills, boring heads or boring bars, back bores, taps, rigid taps, spot face, reamer, countersink, round over tool, and then we can create custom tools as 2D form tools, meaning we're drawing the geometry for it, or 3D form tool means we have a solid model of it. Additionally, we have our broaching tools if you have broaching in your post processor, and we have probing if you have the probing option and probing on your machine. You can do that here as well, but we're going to stick with the basic tools for right now. Alright, so those are our tool options. If I click the CAM button up here, it opens up another tile list below my tool list. This is called the process list. And then on the right hand side of the screen I have another tile list called the operation list. The operation list is kind of the finished product. It's the tiles that will be in here will represent actual toolpath. The software will create these tiles when toolpath is calculated and generated. If you delete one of these tiles, you've deleted that toolpath from the program. Now the processes, on the other hand, is your plan. It's kind of your intention. How do I want this toolpath to behave? It is not toolpath, it's your plan for toolpath. So you may take a tool, let me make this something different, I'll just make it an end mill for right now. So you take a tool and bring it down. You select the type of toolpath you're going to create with it. Let's just say we're going to do a contour for the time being. And it opens up a dialog for you to describe how this tool is going to behave. How fast we're going to spin the spindle. How fast are we going to feed on our entry and on our contour. Do we want an entry exit move? If so, what kind? extra offsets in this case for a contouring process. Are we cutting to finish size, or are we leaving stock? Are we leaving Z stock? Yeah, overlap, spring passes, our Z depth controls over here, our step downs, some options when you're taking multiple step downs. We're going to talk about all this in detail when we get to contouring. Some other options, coolant choices, things like that. Once you have done that and you select the geometry, it'll activate the Do It button, and if you hit Do It, once you've just defined what you want to cut, and the software will create one or more operations based on machining the selected geometry with the strategy you defined as in your process. All right, so we're going to talk a little bit about managing the operation list, especially when we get to get some toolpath created, because that's probably one of the most important things you'll do as a GibbsCAM programmer. The software will let you screw up, and so if you mismanage this list, it's very easy to delete something that you didn't intend to delete, or overwrite something you didn't intend to overwrite, or create toolpath with tools that you didn't intend to create the toolpath with. We're going to talk more about that here once we've got the holes in this part. All right, so let's get started on this part. Let's look at our drawing again. We have 4 holes. We're going to ream 3/8. So I need a center drill or a spot drill. I prefer spot drills.
Center drills for light.
Yeah, I prefer spot drills, and I'm going to use a 23/64, so 64 smaller than 3/8 drill, and a 3/8 reamer. So those are the 3 tools I'm going to create. So tool 1 then is going to be a spot drill. I like a 3/4 inch spot drill, 90-degree 2 flute, and that is going to be solid carbide. Now, I can enter a comment here, and I generally recommend doing that. I won't do it for all of our tools that we're doing in the exercises simply for time's sake, but I'm going to call this 3/4 inch carbide spot drill. The advantage of entering a comment, number one, it's clear if you're not the person setting this up, or if you program this today and run them tomorrow, and then a year from now you've gone somewhere else and somebody else is running this, it will give them a little bit more information as far as what your intention is. Also, inside of GibbsCAM, if you just point to a tool that doesn't have a comment, it just calls it a tool. But if you point to a tool that has a comment, it shows you that comment. So it's a little easier to tell what you're looking at over here. Sometimes you may have more than 1/2 inch end mill, and that the comment will tell you which one is which, if one's a stubby and one's a or one's a 3 flute and one's a 5 flute or something like that. All right, so 3/4 inch spot drill, that's all good, 2 flute. All right, and then tool 2, I'm going to use a drill, and that's going to be a 23/64. Now, I know the decimal equivalent of 23/64, but I don't have to. I can just enter that as a fraction. 23 divided by 64, that's all a fraction is a division problem. 23 divided by 64 is 359 and some change, and that's our tool. Since I'm spot drilling this, I'm just going to use a 118-degree, just a standard jobber drill. We'll say it's got 2.5 inches of flute, and it's 3 inches long, or 3 inches out of the holder. That's also a 2 flute. I'll say 23/64. That would actually be a cobalt or a high-speed steel drill more than likely, but we're going to say it's carbide drill, and that would be a jobber drill, which would not be carbide most likely, but we'll do it that way anyway. All right, and then tool 3 is going to be a reamer. The diameter is going to be 375, and we're going to say that that's a 4 flute. All right, now a couple of things I want to point out here. This is a chamfer on the end of the part, and this is a non-cutting flat on the end of the tool. I have told people before to zero that out, but the problem with that is if there's no chamfer, it shows that going from this diameter at the top of the flute to this diameter at the bottom of the flute. To me, this is a bug. I've reported it, but anyway, if you get these numbers probably correct, then it looks right. So if we say a 10 thousandths chamfer, it looks correct, but it's actually not still. If I don't know if you can see that, but basically you've got 10 thousandths from here to the tip of the tool, and over that 10 thousandths it's tapering from 3/8 down to 0. So for this to truly be correct, for the picture to be truly correct, this would need to be the actual number for the flat, the non-cutting flat on the tip of this end mill, which needs to be smaller than our drill diameter. So let's just say it's 340 thousandths, and now the tool is actually structured correctly. So, you know, this could stay at 1 and it would be fine, but then the entire tip of that tool is considered a non-cutting surface. If you have gouge checking turned on, it will detect that as an interference. So I usually try to set this up correctly. All right, so these are the 3 tools they want to use. I'm going to show you 2 ways to generate this tool path. The easiest way to get your head wrapped around first, and then I'll show you the right way to do it. And there's several reasons why it's better. I'm going to use this to explain why it's better. And this is a very simple part. We're only dealing with 3 tools. We're only going to be dealing with 3 operations over on the right hand side when it's all said and done. Just remember that some parts are going to be a lot more complicated than this, a lot more tools, a lot more operations. So that'll help you understand the importance of what I call multi-process operations, where we do all of our machining in one process list. All of our machining for one group of holes or one contour or one set of pockets or whatever. But the way that a lot of people do this, because it's easy for them to wrap their head around, is single process operations. So I bring the spot drill down, I say I'm doing holes with it, and I set that up. I'm just going to do a feed in, wrap it out. Now let me run through these real quick. Since not every machine uses the same G codes for their can cycles, Gibbs uses words to describe the can cycles rather than saying a G81. It says feed in, wrap it out. Feed in, feed out, feeds down to depth and feeds back out. That would typically be a reaming cycle, a G82 on some machines. Tap is a G84 on a lot of machines. Rigid tap could be almost anything. If you got a Haas, it's just a G84. The rigid tapping cycle takes over, and there is no non-rigid tapping cycle. Other machines, it may be a G184, it may be a G84.1 or a G84.2, or one generation of Fadals had to have both a G84.1 and a G84.2 to activate rigid tapping. PEC full out G83, chip breaker PEC, G73, and then you have rough mill bore, finished mill bore, and helix bore. All 3 of these choices are designed to generate a larger circular bore with a smaller end mill. So it interpolates to rough out, which is essentially pocketing, and then finishes essentially contouring, and helix bore starts at the top and spirals through. With any of these choices, the bore tab is activated. If I'm on any other choice, the bore tab is not even available. But as soon as I get to rough mill bore or finished mill bore or helix bore, it activates and gives me some settings to control the bore size. I usually try to use the circle diameter to control my bore sizes. That way I can do multiple sizes in one process. But these are your bore settings for any of those 3. Rough mill bore, finished mill bore, helix bore. Your controls, your primary controls will be under the bore tab. Let's see, and then you have this one, which everybody calls bore, but this is really just other. So you click the drop down, and you have bore, fine bore, and back bore are what are installed here. But if you create any custom drill cycles, those will be in this list as well. Keep that in mind. All right, so for this tool, my spot drill, we're just going to feed in and wrap it out at G81. I can click RPM and feed and get the numbers from the cut data database. I like to go a little faster than that. I'm going to go 2500, which is still not very fast, and about 30 inches a minute. If I want to give it a dwell, this is in seconds, so 0.2 would be a 0.2 of a second dwell. And then we've got some other options here. One direction approaches every hole from a positive direction. This would only be valuable or needed on a really old lead screw machine where where you got some slop, and if you don't approach every hole coming from the same direction, they may not be quite correct relative to each other. On a newer machine, this is not an issue. Now over here we have our Z values, and we need to talk about these for a minute. Every GibbsCAM process, assuming that you're on dimension from tool, which is where we're going to stay for a little bit, then every GibbsCAM process will have either 4 values in this area or 6 values in this area. The 4 values that are common to every GibbsCAM process are going to be this number with a down arrow next to it, or an arrow pointing toward the part, if you will, from the tool to the part, which is down here on the lathe that would be to the left. But this is where the tool is going to rapid to before it begins this machining. So in the document control, this clearance value, if I make that 2 inches, for example, it's going to move to the XY position of the first hole. It's going to rapid down to 2 inches. Then it's going to start looking at the process data, and it's going to rapid down to 0.1. This is the point at which it's going to begin the drill cycle. It's going to do the drill cycle. It's expecting the top of the part to be here. It's going to go to this depth, and when it gets finished, it's going to rapid out to here. Then, assuming that's the last hole, it's going to rapid to here, and then go to the tool change. So it's kind of important to understand the order that those happen in. But every machining process has the rapid down value. They also have a clearance value with an up arrow, which is where it's going to rapid out to at the end of the process. If for non-drilling or non-hole making processes, it'll also rapid to this number to move from one location to another. The top of the part value is this, although it's not really the top of the part value. This is actually the Z value that your toolpath gets calculated at. And that's an important distinction in some cases, but for the time being, you can consider this to be the top of the part value. Now notice it drew a red line over to here, a red arrow over there. We're going to get to that in just a minute. Every machining process also has this number, which is how deep this tool is going to go, measured at the tip of the tool. Okay, so this is the Z value that the tool is going to go to. Now, so every GibbsCAM process has at least those 4 values: rapid down, rapid out, top of the part or toolpath calculation depth, and machining depth. All right, now if you were doing a hole making cycle and your tool has a point on it, which we're doing a hole making cycle and our tool has a 90-degree tip on it, okay, then you get 2 additional values. And you see when I clicked on this depth, it drew a red arrow to these 2 values that we haven't talked about yet. What these 2 numbers are, or these 2 fields are, is they allow you to calculate this number. This number is what's going to go in the program regardless. But there's really kind of 3 situations that you might have with a drilling operation. Let's just say you're drilling a pilot hole to drop an end mill in where you're machining a pocket that's got a floor in it. Then you're concerned with where the tip of that tool is at. You don't want the tip of the tool to get down into that floor, but you want it to go down as far as you can without getting into that floor to give you as much clearance as possible to drop your end mill into. In which case, you simply enter how deep you want the tip of the tool to go. But there are other situations where maybe you've got a 23/64 drill, like we're going to have in just a minute. We want to drill all the way through a 1-inch thick block. If that's the case, I can enter that number here, how deep I want the shoulder or the full diameter of this tool to go, and it'll recalculate the tip depth based on what the shape I told it the tool had. Now remember, this is a 3/4 inch diameter with a 90-degree tip, so this is not a tool I would actually drill all the way through. But if I entered minus 1.02 there, it recalculates the tip depth based on the geometry of the tool. When the tip is this deep, the full diameter is going to be that deep, and that's what I would need if I were trying to drill all the way through this with that. The other situation, which is actually the case here, typically with a countersink or a spot drill or a center drill, I'm concerned with the diameter of the tool that's at the top of the part when it's at full depth. In other words, the chamfer diameter that's going to be created with this tool. So in this case, these holes are going to end up a 375 diameter, so I'm going to enter a chamfer diameter of 0.4. 25 thousandths bigger than the finished diameter. That'll give me a 12.5 thousandths chamfer all the way around this hole. And it recalculates how deep the tip's got to go to give me that. based on the geometry that I told it the tool had. All right, so keeping those in mind, and this number will be calculated at this Z depth here. So wherever you... Go ahead.
Change that to 0.406 and see what it changes the numbers to.
What changed this to 406?
Yeah, okay. The depth change
Yep.
automatically.
Yep. All right, so now the other thing that we can control is the transition between holes. Remember I said if we weren't drilling, this number here would be where it would go to between locations. But with drilling, we can set a retract plane wherever we want to. We can retract to this number, the R level. We can retract to the part clearance plane, which is what's defined on the document control dialog, or we can retract to an absolute Z and punch in any number we want to as the height that this thing's going to move to between holes. So keep that in mind. You can also retract or transition based on a hole feature, which we haven't gotten to that yet. We'd have to be on dimension from hole and defining features for that to be valid. We're going to retract at the 0.1 value right now. All right, vary depth with geometry means that if you've got, let's just say that this hole was at 0, this hole was at minus 0.1, this one at minus 0.2, and this one at minus 0.3 in the Z. And I select all of those, and I start with this hole first, and I tell it to go 200 thousandths deep. Well, this was going to go 300 thousandths deep, this was going to go 400 thousandths deep, and that was going to go a ½ inch deep, because it's going to go to the same depth relative to where the point's at as it does on the first hole it goes to. So therefore my recommendation is to leave that off. Now if all your geometry is at 0, which is where it typically should be, this doesn't matter, but there's no reason for that to be on unless you specifically want it on, so I recommend turning it off. Reverse order is self-explanatory, and we'll get to that in just a minute. We're going to run coolant, flood coolant, and you can have your post modified to add other coolant choices if you have multiple coolants. Any questions about this page? All right, I'm going to go ahead and close that, and I'm going to generate toolpath for those 4 hole locations. Now remember, this is not the way that I want you to do it, but this is toolpath creation at its most basic level. And there's our toolpath. If I go to an isometric view, go to my op sim, there's a model of my part. I'll slow it down, and that's the simulation of that toolpath. Okay, so I'm going to clear this out. I'm going to bring this tool down. I'm going to do holes with it. I'm going to move a little bit quicker now that I've explained the options in here. I'm going to do a chip breaker peck. I'm going to kick this up to about 6,500 RPM and about 50 inches a minute, and I'm going to peck this at 1/8 inch increments, which is kind of babying this thing a little bit, but that's okay. And I want this thing to go all the way through the part, so I'm going to set a shoulder depth or a full diameter depth of minus 1.02, which gives me this number for the tip depth. Now, what I'm about to do is totally unnecessary, but I would do it anyway. I don't like 5 decimal places or 4 decimal places. I don't even like 3 decimal places for a drill depth unless it's absolutely necessary. So unless I were running 10,000 of these, in which case I'd program it differently anyway, I'm just going to round that to 1.13 deep. It's going an extra 2 thousandths deeper than what I had planned. I'll never notice that. So, and this is a lot easier to read in the machine. All right, so we're going to say do that. And then, yeah, I just right-clicked anywhere on the screen and hit do it. You can also hit it here, and you can also hit it here, up here. But generally, I just hit it wherever my mouse happens to be at on the screen. I'm going to go do a feed in, feed out, 1.1 deep at the tip of the tool. I like to ring fairly slow, so I'm going to go 900 RPM and about 12 inches a minute. And then I'm just going to right click anywhere on the screen and say do it. So this part is programmed. I'm going to clear that out, and I'm going to run the full simulation, all 3 operations. I'm going to single block through it. So we spot drill, we change to the drill, go back to the first hole, and then we come back to the first hole again and ring. All right, Now, it's not really an issue on a part this small on a reasonably fast machine, but just for cleanliness, I'm probably going to go back into the drilling. And notice I just double clicked on it to reload it over here, but also made sure the geometry was selected. And rather than selecting the geometry in a different order, I'm just going to tell it to reverse order and redo. And that overwrote the yellow operation, the selected operation, with whatever was in the process list. And we're going to talk a lot more about that here in a few minutes. Now I'm going to single block through this again. So now we're spot drilling going in this direction. It's going to change tools, but it's going to stay at that hole, and it's going to drill them coming the other way. And it's going to change tools again, staying over that hole, and ream them in the original direction.
If you had more options, just check every other one.
Right, if they were all part of the same hole set. All right, now let me close that and let me demonstrate one of the reasons why I don't like single process operations. Let's take this hole here, and let's just say we get an engineering change and that hole moves 1/4 inch to the right. Okay, so I've moved that hole. Now my toolpath is incorrect. I've got to redo each one of these. Double click, right click, redo, double click, right click, redo. Now I could right click on one of these and do redo all operations, and I could get away with that easily with something this simple. But on a more complex part, I want to verify the toolpath at each step of the way myself. Make sure that it's starting where I want it to start, going the direction I want it to go. So I don't use redo all operations on complicated parts. That's the reason number one. Reason number two is it defeats the advantage, or defeats 90% of the advantage of saving processes, which we're going to talk about here in a few minutes too. Saving processes is a huge benefit. It's a huge tool that a lot of people don't use effectively in GibbsCAM. But if you learn to use it effectively, it can save you a boatload of time programming parts. All right, so let me delete all this toolpath. I'm just going to select all of those and throw them away. And I'm going to do this again. I'm going to do it what I consider the correct way. So I'm going to start out with tool 1, bring it down, and set it up. I'm going to create holes. Pretty much exactly the same thing I did before. I'm going to do this at 2500 and about 30 inches a minute. And that's fine, that's fine, that's fine. I'm going to do to a diameter of 0.4 and move between holes at 0.1. I don't need to reverse the order on this, but I'm not going to create a toolpath. I'm going to take tool 2, bring it down to number 2 here. I'm going to do holes with it, and I'm going to do a chip breaker peg, G73. I'm going to do that at about 6,500 RPM and about 50 inches a minute, 1/8 inch peck. And I'm going to send this all the way, the full diameter, all the way through the part, plus a little bit, minus 1.02. And again, 5 decimal places. I'm going to round that to certainly no more than 3 decimal places. And I want to reverse the order on that one. And then I'm going to bring my reamer down to number 3. I'm going to do holes with it, feed in, feed out. I'm going to do that at 900 RPM. And about 12 inches a minute, and I'm just going to go 1.1 deep at the tip, and don't need to reverse order on that one. So what I've done is I built everything that's going to these same hole locations. Now if I had other size holes, these wouldn't be in here to go there, okay, and I wouldn't add the stuff for the other holes down here. This is only for the toolpath that I'm creating right now. The toolpath I'm creating right now is these holes. So anything that's part of these holes can be in this list. Anything that's defined by these 4 point locations can be in this list at the same time. All right, so I'm going to select all of those and say do it. All right, watch this run. I'm not going to single block through it this time. And our toolpath looks like this. Okay. Now, what is the advantage of doing multi-process operations? All right, let's take that hole and let's move it back where it originally was. I'm going to translate to -1/4. or translate it minus a quarter. Now all I got to do is double click, which reselects the geometry. It selects everything that's created at the same time, reselects the geometry, and rebuilds the process over here. All I got to do is hit redo, and it redoes them all at one time. That's advantage number one, but the big advantage to me is there is value in saving this process. I may want to ream a 3/8 hole again, in which case I'm probably going to use the same tool set. So I can right click over here, go to Save Process List. It goes to my process folder, and I'm just going to go to Miscellaneous Holes. Hopefully I can remember that. And I'm going to call this ream .375. Oops. Try that again. Ream .375 through 1 deep. Good grief. What is this doing to me? Yeah, it lost the folder. I think I was hitting the touchpad. So I'll go to my process folder right here and back into where did I put that? Miscellaneous holes. And I'm just going to put ABC after it because I've got another process in here that has pretty much the same name. All right. Now, what does saving that process do for me? It allows me to quickly and easily call up that process. I don't know why this is taking so long. The video is probably, we're at over 30 minutes, is probably eating up all of my resources. Okay. All right, so having saved that, I'm going to now open up another part. So I'm going to save this one, and I'm going to open sample 2. All right, sample 2, make a slight change here. Sample 2 has this bolt circle that is specified as 3/8 holes. Now, almost certainly these would be 13/32 holes clearance for a 3/8 bolt. But we're going to pretend that these are supposed to be 3/8 ream holes. So I'm going to open up my tools in my CAM, and notice I have no toolpath, I have no tools built, I've got nothing here. So I'm going to right click, go to Load Process List, and it shows me all the folders that are in my default process folder. I'm going to go to Miscellaneous Holes. Miscellaneous Holes, I'm going to find the 3/8 ream, or ream 3/8 ABC. That's the one that I just created. And it will build my tools for me automatically. It will build my process for me automatically. And all I've got to do, if I need to change the depth of something, I can change it. But I select the holes that I want to do, which is going to be the bolt circle, and say do it. And that's done. So let me clear this out. Let me right click and go to Load Process List, and let me go to my pocketing processes. And let me just grab one that'll go all the way through a 1-inch thick part, and select that and say do it. And let me clear that out, and let me right click and go to Load Process. Give me a tap size, any tap size. It's got to be less than a 1/2 inch because these holes are only a 1/2 inch apart. 3/8/16. So I'm going to go tap it with center drill, 1/4 to 1/2, 3/8/16. Builds the tools for me. Select those holes, do it, and this part is programmed. So let's go to OpSim. And the nice thing is, this is not some software engineer deciding how I need to machine this. These are, I built these processes to machine the way that I wanted to machine, and then save that, and then I can apply it to other parts at will. I can still go in, I can go into these processes if I want to, take larger step downs on that bore, for example. I could load that process back in, go to my roughing, and say, let's take that in 3/8 steps. and recalculate it. Now we're taking it in actually 347,000 steps, I think. But and then if I wanted to, I could say this is an entirely new process as well. I'm sorry.
It splits it up for you.
Yeah, it's going to be an equal step down based on, and we're going to talk more about that here in a few minutes when we get to contouring. But saving processes is a huge deal if you put them in a directory structure where you can find what you're looking for. Now mine is kind of a mess because I use it for classes and demos and everything else, but I've got some real processes in here that I use on a regular basis. And you see I start out with the type of process it is, and then get more specific, and then and you can just cascade it so it's easy to find what you're looking for. So you put it in a directory structure that makes sense, and then you give it a name. So I can tell 10 years from now I'll be able to tell you this is going to pocket using a 1/2-inch drill, then a 1/2-inch roughing and mill, 3/8 finishing and mill, 3/8 chamfering tool, and it's going 3/4 deep. Now I've changed. This is an old one. I've changed my naming convention since then, and I almost never drill a pilot hole anymore. I generally helix through with my or helix down with my end mill. But all of my processes are set up. All my real processes are set up for aluminum, unless it specifies otherwise. So you see down here we're pocketing steel, so the feeds and speeds are set up for steel rather than aluminum. But the shop where I started using Gibbs at did 90% or more of what we did was either aluminum or plastic. We did a lot of mold prototyping, so we did a lot of stuff out of aluminum and plastic. All right, so we haven't talked about the pocketing and the contouring I did here yet. We're going to get to that in a minute. But what I'd like you to do is open up sample 1, and also from this point forward, you don't have to do what I do. If you would use a different selection of tools to create 3/8 ring holes, use whatever you would actually use. Use the speeds and feeds that you would use for the material that we're specifying, and just. I want to make sure you can create the toolpath that you want to create. You don't have to create the toolpath that I created. It just has to be correct.
We were talking about the tool library. You don't have one saved for the tools, as far as I know. I can't find it.
We'll talk about saving tool libraries, but it wouldn't really surprise me. A lot of people don't save their tool libraries. But you can select tools in your tool list, right click, and save the selected tools, and you can have as many tool libraries as you want. Just call it the one that you need, and it works the same way as processes. Once you've saved some tools and you've defined a default folder, you go to load tools and you can select whatever library you want to load there, and you can set it so that they always go to the same numbers as long as that position is not taken. So if you start out from an empty tool list, it'll always put them in the number that you saved them in, if you select that option.